Welcome everybody. Today we will be discussing about the technique for solving AC circuit or AC circuit analysis. So to solve any circuit, for solving AC circuits, we need to transform the circuit to the phasor form or in frequency domain. So meaning that if the circuit parameters are given in time domain, like voltage or current are given in time domain, you have to convert it to its phasor form or in the frequency domain. And also if the inductance or capacitance are given in uh, henries or farads, then we need to convert them in impedance or ohms using frequency domain concept. And then we have to solve the problem using the circuit analysis technique like the nodal voltage analysis, mesh current analysis, superposition, source transformation, Thevenin theorem or Norton's theorem, and so on. And finally, we need to transform the resulting phasor to the time domain if necessary. Sometimes we might ask you to express your result in time domain. Then you need to convert your obtained frequency domain result to the time domain. So the first part, like converting time domain to frequency domain, not always required. Sometimes we provide the circuit parameters in frequency domain. So if circuit parameters given in frequency domain, we don't need to convert time domain to frequency domain because it is already given in frequency domain. And sometimes the last step, like converting frequency domain to time domain, is not necessary because we might ask you the result in frequency domain. Let us solve this circuit using nodal analysis method, node voltage method. So in node voltage method, as we discussed in DC circuit, we will be using the same concept for AC circuit. So at first we need to identify the nodes. Here we see one node is here because at this point capacitor, this resistor and these inductors are connected. And also we see another node is here. So in this node we have an inductor, a resistor and capacitor is connected, and there is a node here too. This node is, we have a dependent voltage source, and the value of this voltage source is 3Vx, and this Vx is equal to V1. Vx is equal to V1, and there is another, this node got a voltage this cosine, and we have the reference node or ground connected down here. So we need to solve this circuit. As at first you see the values are given in time domain. This is in time domain, and the inductance given in Henry and capacitance given in farads. So we need to find this in phasor form or in frequency domain, and also we need to find the impedance for this and impedance for this, impedance for this inductor and impedance for this capacitor. So let me redraw the circuit after let me redraw the circuit converting it to frequency domain. So if I convert this circuit to frequency domain, you will see here so to convert this, you will see we have 10 cosine 2t. So 10 is the amplitude of this voltage current. Sorry, we have to write 10, and there is no phase angle, so the phase angle is 0 degrees. Simply you can write 10 0 or 10, because 0 degree has no mathematical contribution, so you can write 10 amperes. This is AC, so you see 10 amperes per I, and the frequency of this is 2 radians per second. 2 radians per second, that is the frequency. Now we have to find the inductance and the capacitance, the reactance for this capacitance, and the impedance of this inductance. So impedance of this capacitance and impedance for this inductance. The impedance of this capacitance is ZC. ZC is equal to 1 over negative j omega times C. Here j and omega is 2 and C is 0.2, and you will get negative 2.5 ohms. So obviously the impedance of capacitor will be negative 2.5, negative imaginary value of 2.5, so always negative. The impedance of capacitor is always negative. Now we find the impedance for the inductor, and as you see, the impedance of the inductor will be j omega L, and this 2 times 2, omega is 2 and L is 2, 4 ohms. So we leave the resistance 2 ohms, so this is already in ohms, and this will get 4 ohms, J4, and this will be negative J 2.5 ohms, and this is 4 ohms, and this is 3 Vx, and Vx equal to V1 over here, and V2 is there, so 3 V1. So now I produce my circuit in the frequency domain. So this is the frequency domain circuit. So we'll be using this frequency domain circuit and write the node equations based on this frequency domain circuit. So in this frequency domain circuit, you see the current, incoming current is 10, so you write negative 10, and the outgoing current here will be V1, this is my ground, so V1 over minus 0 over 2, so V1 over 2, then V1 minus V2 over negative J 2.5, and is equal to 0. So if I simplify this, you will get 0.5 V1. So if you remove negative J on the top, that will be positive J, you know. So if you have a J, you can write it like negative 1 over J, so that is negative 1 is J squared over J, give us J. So 1 over negative J is equal to J. Similarly, if you have 1 over J, that will be equal to negative J. So now if I simplify this equation, so you get 0.5 and 0.4, 0.5 plus 0.4 V1 and negative J 0.04, negative J 0.4 V2, 10. This is equation 1. And then for node 2, at node 2 you can write the equation, node equations. In this equation, let's assume V2 over 2, 4, V2 over J4, and V2 minus V1 over this negative J 2.5, V2 minus V1 negative J 2.5, and V2, this voltage will be 3 V1, V2 minus 3 Vx over 4 equal to 0. So basically this Vx will replace by V1 here, so 3 V1, and I simplify this equation. 1 over 4 is 0.25 and 1 over J is negative J, 1 over negative J is positive J, 0.4 V2 minus V1, and 0.24, 1 over 4 is 0.25, V2 minus 3 V1 equal to 0. Then we simplify this, we take all this V1 together, so V1 has negative 0.04 and 0.75, negative 0.04, and V2 has 0.025, then 0.04, and this, so I write V2 here. Now we got two equations, one equations here from node voltage 1, and second equations over here for node voltage 2, and these two equations we need to solve. Remember, we cannot use calculator for solving complex mode equation, unlike in DC. For DC we could solve equations using calculator, but here we cannot solve them using calculator. So what we have to do, we have to write them in matrix form. So how to prepare the matrix? So to prepare the matrix, we write the coefficient of V1 in the first row and first column, then coefficient of V2 in the second column, and then coefficient of V1 in second row first column, and coefficient of V2 in second row second column, and this is V1 and V2, and the constant, the right hand side term 10 and 0 over here. Now we can solve this matrix. So to solve this matrix, you have to multiply this with this, then minus the product of this and this. So product of this and this minus product of this and this. So we have to find, this is the delta. So let's say this is delta. Delta is the first left part of this matrix. So the left part of this matrix, I multiply this with this and minus this with this. We can use calculator for doing this, and you will come up with this value. Now I have to find delta 1. Delta 1 is formed by replacing the first column of this matrix with the constant term, right hand side term. So I replace this with 10 and replace this with 0. So then we form delta 1. So we write it 10 and 0. This second column remain the same, and we solve it for this. And delta 2, we keep the first column as it is and replace the second column with the constant term from the right hand side of the matrix. So we got 10 and 0. So we got this one. Now V1 will be delta 1 over delta. So delta 1 that we solved here over delta, this one, and you got this in. So right away you will get in rectangular form. I recommend you convert in polar form, and then we solve for V2, and when you solve it you will get this one. So usually the values will on the calculator shows the value in rectangular mode, so you have to convert to the polar mode and you get this number. The advantage of using polar form is to converting them in the time domain. We need magnitude and the phase angle. So this is the magnitude, this is the phase angle. So we can use these values for converting their equivalent time domain expression. As the question asking for finding lowercase v1 and lowercase v2, that means we need to convert in time domain, and we can easily do this. So I take the magnitude of this and cosine, the frequency is 2t and the angle is 60.02, and v2 is this 2t and 57.127. So this is how we can solve circuit using node voltage technique. So to solve this, basically you need to identify the nodes, assign the node voltage, and then write the node voltage equation by the help of KCL, and then you simplify those equations, form matrix, and then find the values. Be careful, the formula is delta 1 over delta and delta 2 over delta. Sometimes a student makes mistake and they write it opposite, like delta over delta 1 or delta over delta 2. So be careful about this formula here, delta 1 over delta and delta 2 over delta. Let me solve an example using nodal analysis. This is another example using nodal analysis. In this case, we have a node here, B, and another node here, and this is my reference node. And you can see there is a voltage source between two non-reference nodes. So as we know from our DC circuit analysis method, just if you have if you have a voltage source connected between two non-reference nodes, then we have to include these two nodes together and to form a supernode. So here we have to have the supernode including V1 and V2. This is a supernode here. Now also you see here the values are given in frequency domain, so we don't need to convert the time domain to frequency domain because right away we have the frequency domain numbers. You see the symbol of voltage source as a positive, negative. This is very same symbol for DC circuits, but only the difference is the magnitude. You see the value here, the amplitude has magnitude is 75 as a phase angle. So if you have same symbol but the phase angle with the included with the number with the source, this that represent the source is an AC source. So if you see the phase angle given with the value of the voltage source, then the voltage source will be a AC voltage source. So this is a AC voltage source, this is also AC voltage source. Now let me write the node voltage equation, node current equation using this node voltage. So for this node, super node, you see the V1 minus 75 over 4, the current in this direction, then V1 over J4, and then V2 over negative J1 and V2 over 2. So we got this mesh equation, and also we got V2 plus 160 equal to V1, V2 plus 160 equal to V1, or you also can write it like V1 minus V2 100 equal to 160 degrees. Now we replace our V1 with this V2 160. So V1 with this V2 160, and then simplify my expression, and finally we got the value for V2, and I convert the value for V2 in the polar form. Then we can find V1 by adding V2 with this. So we use this equation or this equation to find V1. So this is the value for node voltage V1 and V2. So now we have learned about how to apply nodal analysis method for solving any regular circuit and also a circuit with supernode. Now we will be discussing about the mesh current analysis method for solving AC circuit problems. Let us solve this circuit showing here. So in this circuit we have 1, 2, 3 mesh. So we need to identify the mesh and then assign the mesh currents. So let us identify the mesh here. So we have mesh 1, mesh 2 and mesh 3. This mesh I assign the mesh current I1. For this mesh I assign the mesh current I2, and here I assign the mesh current I3. Now we have to write Kirchhoff's voltage law using this mesh current. So for this mesh we have to write 8I1 minus 2JI1 plus 4JI1 minus I2. This element is shared by two mesh. So the total current here will be I1 minus I2, because I1 is flowing in this direction, I2 in the opposite direction. So we'll write I1 minus I2 equal to 0. So this is the equation for first mesh. Now I simplify this equation. So 8. So all the I1 coefficient I arrange them together, and the I2 coefficient I arrange together. Then I reduce the I1 and I2 coefficients and come up with equation number 1 for mesh 1. Then I write down the mesh equation for second mesh. For the second mesh, you will see we have 6 shared by I2 and I3. So that 6 I2 minus I3, and a voltage source starting with positive 50 angle 30 degrees, and the current source here 4J shared with I2 and I1. So I2 and I1 equal to 0. Then I write the mesh equation for mesh 3. This is a current source, and so is the current source, you see I3 will be equal to the opposite of negative 10. So I write I3 equal to negative 10, angle 0 degree. So we can write negative 10. You can skip this 0 because 0 degree has no contribution in mathematically. So we write negative 10. Now if I rewrite the mesh equation, second mesh equation, we will get 6I2 and I3 equal to 10. So I replace this 10, and then 50 I3, I2 minus I1. So it will be easier. You can reduce your mesh equation to 2 equations only, that will be easy for solving using calculators. Otherwise it will take a long time for solving. So we need to replace some variables so that we can come up with only 2 equations. So now we got from mesh 2, I simplify further and come up with this equation. Now we write the equation in matrix form. So this is the coefficient of I1 for the first equation, and coefficient of I2. This is coefficient of I1 for second equation. This is for I2, and this is the right hand side for equation 1 is 0 and equation 2 is this. Now we got the evaluate this value matrix, the value of this matrix. So that is delta equal to this. So now I got the number. Like, you see how to evaluate this, you multiply the diagonal component minus this diagonal component, and then we solve for delta 1. To solve delta 1, I replace this first column using this right hand side. So first column using this right hand side, and this is the second column as it is. So then I solve this one. So from the delta 1, I got the number for delta 1. Now I1 will be delta 1 over delta. So I got this one. We don't need to find I2 because we are expecting to get IO. And what is IO? If you look at the circuit, IO is the current in 8 ohms, and that is the same current. The current in 8 ohms is the I1 if you use the mesh current, but in the opposite direction. So IO will be negative I1. So we write IO equal to negative I1. So I multiply this I1 that we obtained here with the negative sign, and we got this. So this is my equivalent polar form. So let me solve another example for using mesh analysis. So we need to calculate I naught, current I naught for this circuit. I naught is the current of 10 ohms, and here you will see we are given AC source of 60 volt 0 degrees and a current source here 20 volt this. Now at first we need to identify the mesh and assign the mesh current. So let me identify the mesh first. So we have 1 mesh, 2, 3 mesh, and I assign the mesh current I1 for this mesh, I2 for this mesh, and I3 for this mesh. And if you now we need to write the uh, Kirchhoff's voltage law using this mesh current I1, I2 and I3. For mesh 1 we got negative 60 starting with minus sign, so negative 60, and then we have to 10I1, and then negative 4j I1 minus I2, and 5I1 minus I3, 5I1 minus I3 equal to 0. Now I simplify this and then start with writing the equation for second mesh, but the second mesh has a current source. Also this current source is shared with I3, so we cannot pass through this current, this branch, so we can skip this branch and form a super mesh. So now we write a super mesh here including mesh 2 and mesh 3. So mesh 2 has 8ji2 and mesh 3 has negative 46i3, then 5i3 minus i1 and negative 4j i2 minus i1 equal to 0. And from this mesh, from this equation, you see I3 is in the same direction for this current source and opposite to I2. So I3 and I3 minus I2 will be this, or you can write I2 plus this equal to I3. So you can write I2 plus 2.4 equal to I3, or simply you can write I3 minus I2 is equal to 2.4 angle 0 degrees. So whatever I3, so if you see I3 is following this direction and I2 is following in the opposite direction. So this is I3 and this is I2. So you have to remove I3, subtract I2 from I3, and the resultant current will be this much, and that is following to this direction, in the same direction to I3. So we got like this. Now I replace I3 using these values, because we do have now 3 equations, 1, 2, 3 equations, but we need to reduce one equation by using this value. So now I substitute I3 from my first and second equation. So therefore I substitute this 6 for I1 4 and I3 equal to I2 plus 2.4. Then simplify this equation. So this equation is basically based on I1 and I2. So you have two variables and I2. So this is the equation for mesh 1. Now we can find the equation for mesh 2, super mesh. So for super mesh, if you substitute I3 with I2 plus 2.4 and I3 equal to I2 plus 2.4, then we simplify this equation and eventually come up with this. So this equation number 1 and 2, we put them in matrix form and we build this matrix. After finding this matrix, we find this value, the value of this part. So this part is this one, and then we have to find delta 1. That means you replace this one with the constant terms. So we replace this one with the constant terms, then we come up with delta 1. Now delta 1 over delta equal to I1. So I1, and then we got this value for I1, and then we can get the polar form of this. Therefore in this case we have to find IO. IO is the component current in 10 ohms. So basically 10 ohms is equal to the same mesh current I1, because I1 also pass through this 10 ohms resistor, entirely shared by this 10 ohms resistor. So you see I1 and I0 will be same. So now we can replace my component current with the mesh current. So IO will be I1. Now we got IO equal to I1, and this is the value for I1. So this is the rectangular form, this is polar form. So if we ask only for I1, you can leave your answer either in rectangular form or in polar form. So I will be discussing about superposition theorem, how to use this principle for solving AC circuits. So superposition based on the theory that if we have more than one sources powering up a circuit, then the resultant effect or the net effect of the circuit will be sum of the individual effects. So if you look at this circuit here, you can see two AC sources is powering up this device. So the resultant effect on resultant effect of this circuit will be, or resultant effect voltage or current for any component in this circuit will be sum of the voltage or current for this source plus and this source and this source. So when we solve this circuit, we have to consider that this source working alone and find the response because of this source only, and then we solve the circuit using the other source and find the response for this source only, and then we sum them up together to find the net effect or the resultant effect. So in this case, we need to see that we have one voltage source 75 sine 5t and a current source 6 cosine 10t. The frequency is not same, so the problem we solved so far got the same frequency, but here we have two different source frequency sources, two different um, power source with two different we have different power source with two different frequencies. So that means, as you know, the XL, the inductive reactance, is omega L, and Xc equal to 1 over omega C. So frequency has a strong effect on the inductive reactance or capacitive reactance. So as the frequency increases, inductive reactance will increase and capacitive reactance will decrease. So therefore, the value for this impedance of this inductor or capacitor will not same for this source and for the other source. So this type of problems can be solved only using superposition theorem. You cannot use mesh analysis or nodal analysis or Thevenin or Norton's for solving this kind of problems. If we have a circuit that is powering up with two different frequency sources, with two different sources of different frequencies, two more than one sources of different frequencies, you cannot solve them using those methods. Only superposition will work there. So here let me solve this circuit. So at first we consider that AC voltage source is working alone. So we are considering that our voltage source is working alone. So we have this voltage source. This voltage source is 10 volt with 0° angle. So we got 10 volt, and so we have a voltage source acts alone. So let me consider this voltage source 75. It is sine, so I write it negative 90 degrees, and then 8 ohms, and we have I find the XC values by using this formula. So Xc will be negative j over omega c, and negative j is omega c is 1 over 2. So I write ZC. So j over omega c equal to 5 for this case, and c equal to 0.2. So you will get negative j. So you got negative j, b01 over negative j, and then I write. So for this case, like we use nodal analysis. So I keep nodal analysis. We use nodal analysis for solving this. So the impedance of this method of this component is Z6, and here the impedance of L will be XL will be j of omega L, and j omega equal to 5, L equal to 1, so 5 ohms. We got 5 ohms, negative 1 ohms, and this. Now we apply nodal analysis method for solving this. So if you apply nodal analysis, you need to attach a ground node here. Then V1 minus 7590 over 8, V1 over negative J1, V01 over J5 is the node equation. And by solving this node equation, we got V01, and the value of V01 is this. Now V01 we can write in terms of cosine. The angle will be 171 degrees. So you can write 171 plus 90 and replace it sine. So it will be 5t minus sine this. So you got V01 equal to 11.578 sine 5 omega 5t this. If you want to solve this with sine reference, you can also write 75 angle 0 degrees, and then solve the circuit using 0 degrees. Finally, your expression will be right away in terms of sine. So it is not necessary that you have to always use cosine as a reference. You can use sine as a reference for this and cosine as a reference for this source. So now we can take current source X alone. So we have a current source of 6, and now the frequency is 10. Frequency is 10, omega is 10 for this case. So I write omega equal to 10, omega equal to 10. So we will get ZC equal to negative J 10 times C equal to C equal to 0.2. So 0.2, it will be negative 0.5 ohms, and XL will be J omega L, and J omega is 10 times 1, so this will be J 10 ohms. So you see, as frequency increases, the inductive reactance will increase, but capacitive reactance will decrease. So now again we apply nodal analysis method for solving this. So in this case we shorted the voltage source, and for previous case you see we open the current source. So I did open the current source, so we had a voltage source. Why do we consider the voltage source working alone? We disable the current source. How we disable the current source? We remove the current source from here. Just we open up the current source and we redraw the circuit. Now when we working on current source only, we shorted the voltage source. We shorted the voltage source and we got the values like this. So the voltage will be V02 over 8 for this component, V02 over J0.5 negative, and for V02 over J10 and negative 6. Then we solve it, we got V02, and then I substitute this or replace this V02. I express this V02 in time domain, so 0 to 3.14 cosine 10 omega t minus this. Now the resultant effect of these two sources together. Now the resultant effect of these two sources together will be B0 equal to B01 and B02. So B01 is this and B02 is this. Both has the same polarity, right? If you look at B01, B01 got the polarity like this. And if you see the B02, B02 also got the polarity like this. So they got the same polarity. That's why we add them together, B01 plus B02, and we get this answer. So let me solve another example using superposition theorem. In this example, you can see we have a voltage source, a current source, and a DC source. So how we can differentiate this DC source? If you look at the symbol, this AC source and DC source got the same symbol. Only the difference is the expression here. The AC source got a time expression, but DC source has no time expression. Sometimes if you give in frequency domain, this AC source will have an angle 0 degrees and DC source will without angle. So just the symbol, don't look at the symbol. The symbol could mislead you, because DC and AC, both voltage source got the same symbol, but you have to pay some attention to the values given next to the symbol. If the value got an angle, that's an AC source. If there is no angle, that is a DC source. So we got 10 volt, and then I am working on AC voltage source only. So I am considering the voltage source only. I open up this current source and shorted this voltage source. So I open the current source and shorted this voltage source. And I also solve for the impedance for inductance. So inductive reactance will be ZL equal to J omega L, and omega equal to 2. So it will be 2 times L equal to 2, 4 ohms. So it will got 4 ohms, and here we will get 5 ohms. So you can get XC equal to negative J omega c, omega is 2, c equal to 0.1, so that will be 5, negative j5 ohms. So that is negative j5 ohms. So now we can solve this using circuit reduction method. So we see the total impedance will be 1 plus j4, and these two are in parallel. So we got 4 parallel j5, 4 parallel j5, and in series with 1 plus j4, the total impedance will be this. Now the total current will be the voltage over the impedance. So you got the total current this. Now the total current is here, so you can find the V01. V01 will be total current times the resistance of this. So this one, so this is V01, and time domain will be cosine 2t 30.78 degrees. So this is the voltage drop on ohms resistor for this voltage source only. Now we have to find the response for the current source. Now we need to solve the circuit for current source working alone. So if you consider this current source working alone, you have to remove this voltage source and this voltage source here. So I shorted this voltage source, AC voltage source, also the DC voltage source, and this time the ZC will be minus J of omega C. So this current source got a value of current source got a current source has a frequency of 5, so it will be J5 times 0.5 times 0.1, so that is 2 ohms, negative J 2 ohms, and ZL will be J omega L 5 times 2, so 10 ohms. So we got 10 ohms here, 0.2 ohms here, and this resistance and resistance. So we can again apply circuit division law, circuit reduction method for solving this. So you see the total impedance at this site will be Z prime. So I solve the impedance of this branch. Here you see 4 and 2J in parallel and in series with 4. So I got this one. So then I draw the circuit, reduce circuit. This is my Z prime. I combine this entire resistance here, that is Z prime and Z. Then I apply current division law. So I prime will be the total current is this times the opposite branch is J10 divided by the total impedance. So you got V02. So if you wanted to solve with cosine reference, then you will get cosine here, and then I reduce to sine, and it is the sine. This is the value for this one. So you see here you cannot add them together because the previous value we solved for 10 omega, now it is for 5 omega, so they should be added separately. Now we have to solve for the DC source. Now we have to solve for the DC source. If you solve for DC source, then we have a DC voltage source here. The AC voltage source is gone, and the AC current source is gone. Also the capacitor that was connected here becomes open because for DC capacitor is open, and this is the inductor, it becomes shorted. So for DC you see ZC will be J of omega C. So omega is infinity, omega is 0, so it becomes infinity, so open, and ZL is J of omega L, and this becomes 0 because omega is 0. Omega is 0 for DC. For DC, omega is 0. So you will get ZL equal to 0. That means short circuit, and this is open circuit. Now if you try to find the voltage here, this voltage current will be 5 over 5. 4 plus 1, they are in series, 1 ampere, so voltage will be negative 1 volt. This is negative 1 because the polarity here, this side is positive, this side is negative, opposite to the current flow, so I write negative 1. Therefore, the total voltage will be negative 1 due to the DC source, and this is for 2 TT source. This is for 2T voltage source and this is for 5T current source. So now we will solve another circuit using source transformation concept. As you know, the source transformation means that a voltage source can be replaced by a current source. By this way, if you have a voltage source here, a voltage source and with a series resistance, you can replace this with a current source with the same resistance to the parallel of this current source. So the same concept we can use for AC circuit too. We see we have a current source here with a parallel resistance, so we can replace this with a voltage source with this impedance in series. So now you see how to find this voltage and current. So to find this voltage will be current times resistance, or if you want to find the current, that will be voltage over resistance. Now you see, sorry, here I should write ZS. So here we have 1290 and impedance is 4 minus Z3. So I replace this current source with a voltage source. How to find the voltage source? To find this voltage source will be 12 angle 90 times 4 minus Z3. So we got this value, and this impedance will move in series. We already have a series resistance here and this. So the other part of the circuit will be, we replace this current source with a voltage source and move this parallel impedance to the series. Now we can combine these two impedances. So this is the value of the voltage source that we compute here, and we combine these two impedances, we form 6 minus Z2, and we got the circuit with like this. Now we have a voltage source in parallel with series. Now I transform this voltage source to current source and move this impedance in parallel. So now we have this current source and two impedance in parallel. Then we reduce this two impedance into a single impedance by parallel law. So we make it, and we don't touch this one because we are interested on finding IO. So we got Z double prime, the impedance here and here. Now we simply apply current division law to find the current IO. So this is current division law, total current, the current of the opposite branch divided by the sum of the impedance of two branches. So we get this. This is how we can apply source transformation method for solving the circuit.